In this video, we'll be talking about the basics fundamental of reading ECG, that is to determine the rate, rhythm, axis, and to say whether it is sinus rhythm or not. So to tell a ECG whether it's sinus rhythm or not, so there are certain criteria to be fulfilled. So the first thing you need to see is the P wave. So here you see here it is the P wave. So here this is the P wave right here this is the P wave, and right here this is the P wave. So let's take the long stripe, that is rhythm stripe, that is lead 2. So you see here this is P wave, this is again P wave, this is again P wave, this is again P wave. Similarly, this is QRS complex, this is QRS complex, and this is QRS complex. So you see here that P wave is coming ahead of QRS complex. Again here P wave is coming ahead of QRS complex. Again here P wave is coming ahead of QRS complex. So always P wave is preceding the QRS complex. So one of the criteria to fulfill the normal sinus rhythm is that the P wave should always precede the QRS complex. So this is one criteria. Now the another criteria is that the PR interval, so this is the PR interval, so this is the PR segment or the PR interval, so the PR interval must be constant. So by that what I mean to say is that suppose this is the P wave and this is the P and this is the case. So again it goes like this, and this is the T wave, so again, and here it comes like this P wave. So you see here this PR interval must be constant. So you see here, so this interval must be constant to be called as a normal sinus rhythm. So sometimes there may be like AV conduction delay or sinus bradycardia or tachycardia, or there can be like AV conduction delay, or different phenomenon can be seen in which the PR interval may be increased. So in that case it may not be the normal sinus rhythm. So these things you need to keep in mind. Now another thing to look at is the lead 2. You see here lead 2. In lead 2 the P wave must be always positive. So this is also another criteria. So in lead 2 the P wave must be always positive. Now the another thing to be looked at is the heart rate. So you see here, first of all you need to determine whether the given rhythm is regular or not. So you see here it is occupying 1 2 3 3.5. Let's say 1 2 3 3.5, 1 2 3 3.5. So somehow it is regular. So to calculate the heart rate there are different formulas. So to find the heart rate there are different formulas. Among them one is to divide 1500 by number of small square box. So number of small square box. So when you divide 1500 divided by number of small square box, so these are the small square box between two peak waves. So you see here this is one peak, so R is here, R wave, and this is R wave here. So you count the number of small square box. So you see here 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. So there are 18 small square box between these R wave. So when we divide 1500 divided by 18, this gives you your heart rate. This is one way to find the heart rate. Another way to find is, so if you have less time, and another quick method is like what you can do is that So you see here it like falls in here. So another method is like numerical method. So here to here it is 300, and here it is 150, and here it is 75, and up to here it is 60. So the heart rate is between 75 to 60. So that way also you can find the heart rate. And another method to find the heart rate, especially it is um, so another method to find the heart rate is like to divide 60 by RR interval. Suppose you divide 60 divided by RR interval. So you see here this is one R and this is another R. So what do you mean by RR interval is that, so this is, you see here, this is one big small square box, one big square box. In this one big square box there are 25 small square box. So one small square box, so if I draw here, so this is one big square box. So inside it there are 25 small square box, and when I take from here, so you will be finding one small square box like this, and let's assume that this is the big small square box. So you take one small square box from here. So from here to here there will be certain number of small square box, and one thing you need to keep in mind is that one small square box, when it rotates through the ECG, it takes about 0.04 second. So 0.04 second will be taken by one small square box. So one small square box takes 0.04 second. So you find, so in this case, in this formula which is 60 by RR interval, so you find that how many small square box are there inside the RR interval, and you multiply them. Suppose let's say it was 18, isn't it? In this case we found to be 18. So 18 into 0.04. So this will give certain value. So 60 divided by 18 into 0.04 will be the heart rate. So this is one way to find the heart rate. And another way to find the heart rate is that, so in 6 seconds you find the number of QRS complex. So let's say, let's start from here. Okay, so as we have already told, one small square box, so one small square box will have 0.04 second. So 1 second will be, of course, 1 second will be 1 divided by 0.04. So 6 second, so 6 second will have 30 large box. So you see here, this is one large box, isn't it? This is 1, this is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So you see here, up to here it is 30 small square box. So up to here, so from here to here, so this is 6 second time interval. This means 30 small square box interval is here. So you count how many QRS complex are there. So you see here it is 1, 2, 3, 4, 5, 6, 7, 8. Oh, oops, sorry. You count in lead 2, okay, because this is the rhythm type. These are different leads, lead 3 AVF. So once again, so we started from here. In 6 second interval time period, you will be having 30 small square box, 30 big square box. So 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30. So in 6 seconds there will be 30 square box, and now in this 6-second interval you count the QRS complexes. So this is 1, this is 2, this is 3, this is 4, 5, 6, 7, 8, 9. So you see here there are 9 QRS complexes in 6-second interval. So by putting the formula, what formula you can put is that the next formula is number of QRS complexes per 6 seconds. So you have 9 QRS complexes and you multiply it by 10, because 6 seconds you have 9 small square box, 9 QRS complexes. So in 1 minute, that means 60 seconds you will be having 90 beats per minute. So this way also you can find the heart rate. So these are the different ways to find the heart rate. So the first being you divide 1500 with number of small square box. That formula also you can apply, or you can apply heart rate divided by RR, heart rate equals to 60 divided by RR interval, or you can do heart rate is equal to number of QRS complexes per 6 seconds into 10. And the last formula which I showed, which was to take 6 second small square in 6 seconds how many are the square boxes. So this formula is especially helpful in case of irregular rhythm. So in normal rhythm you can use other formula. In case of irregular rhythm you can use this formula. So in this video what we concluded is that whether it is normal sinus rhythm or not. So this is the normal sinus rhythm, because the P wave in lead 2, the P wave here, the P wave in lead 2 is positive, and the PR interval is constant, and P is always preceding the QRS complex, and the heart rate falls under the normal range. So these were our finding. So let me quickly erase all these things. Now what we will be talking about is looking at the individual wave. So you look at the P. So to find P wave you look especially at lead 2. So you see the P wave morphology looks normal, and QRS complex, so you can compare it in B1 and V6. So in B1 and V6 there is negative deflection in B1, which is normal phenomenon, and the magnitude is also normal. In V6 it is positive deflection and the magnitude also looks normal. So there is no any sign showing any case of like right ventricular hypertrophy or left ventricular hypertrophy. And again, to find left atrial enlargement you can see lead 2, so it is normal morphology, whereas in lead B1 so you have normal P wave morphology here. So biphasic P wave you can see here. So this is also normal, so there is no any atrial enlargement. Now you can check with the axis whether the axis falls under normal axis or not. So I draw here lead 1, and I draw here AVF. So in case of lead 1 you see here the QRS complex is positive deflection, so the vector will be in this direction, that is positive deflection. You see this is the vector. And in case of AVF, so you see here AVF, the AVF, so you see here AVF, again there is positive vector, so you draw the positive deflection vector. So this will be like this, and now you draw perpendicular imaginary line and you find the resultant vector. So this is the resultant vector here. So when you draw this resultant vector here, so it is falling under 0 to 90 degree. So this is the example of normal axis. So in this ECG it is normal sinus rhythm ECG, heart rate falling in normal range, axis is also falling in normal range, and individual wave like you see T wave, it is also normal in morphology, P wave is also normal in morphology, QRS is normal. So this pretty seems to be normal ECG. So this conclusion can be made from here.